Hi, everybody. We're going to get started in just a second. I sent out the announcement a little later than normal today, so I'm going to wait a few minutes to let people in. So enjoy the music in the meantime, and I'll see you in about a minute or two. Yeah, we'll just start with that theme. I'll just leave that queued up so that when we get to the break, we can listen to that. Hi, everybody. I hope you had a good weekend. I had a pretty busy and surprising weekend, actually. Um, you'll appreciate this more when you're in your 30s. But I caught up with a bunch of friends from like 20 years ago on Discord, and we've all been talking over the weekend. So that was mostly what I did, and then worked on stuff for this class while talking to people. The other thing I did was deal with a cat. What are you doing? Don't meow at me. My cat is meowing at me. She thinks as soon as I start talking, it's time to hug her. But I'm here with you guys, and I can't be with my cat. No, Maya, go away. Oh goodness, she's gonna meow at me. The other thing I did was answer all the emails because a lot of people sent me emails about quiz number 1, and so just as a little reminder for how the quizzes work, remember that this is all in the syllabus and it's also in the orientation quiz. That you don't get to see the answer key until everybody takes the quiz. That deadline is actually tonight at I'll send out another announcement, and then you'll have about an hour to do it. So if you haven't taken the quiz yet, make sure that you do so after class, because it will close tonight. And once it's closed, it's closed. You don't get to take it anymore. Then the answer key will be revealed. Lots of people emailed me with questions like, why is my score so low? And so I went over a few answers, because I can't look at everybody's answer key, mostly because I have to dig for it, and it takes like 5 minutes to look at one person. And a lot of the issues that came up on the quiz were things like not reading the question correctly and understanding it, or just not knowing the material, and answering the questions incorrectly. There are some issues with some specific questions that don't give partial credit. Unfortunately, there's nothing I can do about that. So, like I know the question that asks you to categorize inexact and exact numbers. If you put one of those 6 choices in the wrong spot, you get 0 points. And to be fair, stop that. Sorry, she's yowling now. To be fair, if you put an inexact number in the exact number column by mistake, whether you do 1 mistake or 5 mistakes, the point of the problem is to determine whether or not you know what inexact or exact numbers are. And so if you don't know what they are because you put one in the wrong spot, you don't get credit for it. That's kind of how college level works. Not everything is going to have partial credit, And as much as I would like to just give away points for like, oh, you got 4 out of 6 right, I'll give you 4 out of 6 points. I can't always do that. Quiz number 2 is going to be especially bad about that, which is the quiz that's going to be on Unit 3. I cannot answer that question. In fact, I'm just going to delete that right now because I cannot answer questions about the nature of the quiz while the quiz is still out. Sorry, I can't answer that. I can answer that tomorrow. But quiz number 2 is 5 questions, and it's going to be the types of problems that we've been doing in Unit 3 and also today. And each of them is worth 2 points, but it's right or wrong. And if you don't get the correct answer, you're not going to get any partial credit for it. And that is something that I hate that. Normally what I would do is I'd make it like a 4-point problem on a 20-point quiz, and I'd give you 3 of the points was your work and 1 of the points was your answer. But I have no way to have you type in your work in Canvas that can be assessed effectively. Because I'm not going to ask you to type out dimensional analysis, like hitting the enter key and typing in all the numbers on the bottom. Like that's ridiculous, and formatting is a thing, and so on and so forth. So this is kind of the best option that I have. So I'm trying to make these as low stakes as possible, but still get a general feel of where you are. If the general feel is that you only have about 50% of the points, 2 pieces of advice. 1, don't freak out. Don't flip out that you didn't do well in the first quiz. I got so many emails from people that said, "Oh, I'm failing chemistry. What do I do?" I'm like, "You're not failing. It's 10 points in a 500+ point class. Don't worry about it." Worst case scenario at the end of the quarter is I curve scores up slightly. Like, don't freak out in week 1. Like, it's too early. Second thing to do is wait until the key is out, then compare your answers with the key, and that's when you got to ask me questions. So like, well, I got this as my answer, but the key says that. How come should that have been marked right, or what did I do wrong, or whatever? And then you can ask me. Because obviously right now, if you send me questions about the quiz, I have to send you a reply that says, I can't tell you anything while the quiz is going, but I'm happy to discuss it later. And of course, that sounds like a cop-out, but that's just to be in the interest of fairness for everybody. And I realize that sucks that you have to wait. But unfortunately, that's just sort of the hand that we've all been dealt. Okay, so hopefully that answers most of the questions related to the quizzes. And yeah, so once the quiz key is released, please let me know if you see anything weird. Remember that partial credit is at my discretion. You might get an email back that just says, I can't award partial credit on this question because it's not possible. If you typed in a number in like scientific notation and then Canvas didn't expect that and it didn't render it properly, that I can refund you for. I can look up problems on a case-by-case basis, basically. But very important, if you email me and ask me to look at your quiz, tell me your section number or letter. If you don't, you're going to get a reply that says, what section are you in? And that's going to delay it longer. Because it does take me 5 minutes to sort through 120 people, even with like Control F and typing in names, because I have to go through 5 different pages to do it. Okay, I think that's it for the quiz. The lab is due on Thursday. Tomorrow's lecture will talk about whatever you guys want to. There is no additional lab content tomorrow. It'll just be a Q&A. We're probably going to go over worksheet problems from Unit 3. That's what I foresee this being. So bring questions that you might have. All right, so what are we going to talk about today? We're going to do more conversions. So Thursday, we ended with things like this, where we had to convert units from one case to another. Like, have meters per second, I want it in miles per hour. I want it in furlongs per fortnight. Whatever. On the quiz, I'm going to have you do similar problems, but you're going to see a specific type of problem in this section that is kind of my go-to online, because what's stopping you from typing in, oh, okay, what's this into this in Google? And the answer is, well, what if that unit doesn't exist? And I made up a unit for you. And so a lot of problems are going to involve made-up units, so that you can't just throw them in Google and get your 2 points, because I need to assess something. Okay, let's talk about how to do these types of problems. For instance, if you have a conversion for inches cubed to centimeters cubed, for example, maybe you work at Harley-Davidson, and Harley-Davidson uses these dimensions to measure the displacement of the engine. So, for example, I own an 883 Sportster. And that's because its displacement is 883 cubic centimeters. If I wanted to figure out what that is in cubic inches, I would get a different number. And depending on the size of the engine, you'll get a bigger or smaller number. Cubic centimeters are kind of tiny. So, like, if here was my cubic centimeter with a 1 centimeter side, a cubic inch would be much bigger. Because 1 inch is 2.54 centimeters, right? So a cubic inch must be this number cubed, because it would just be that number times 3, right? Or not times 3, I'm sorry. Raised to the third power. So the way that we make conversion factors for higher dimensions is to do the following. If I write out the one-dimensional relationship, I can raise it to whatever power I want to and create a new relationship. So if I wanted to make this squared, for example, I would do this. If I wanted to make it cubed, I would put a 3 up there. If I wanted to make it 4, I could put a 4 up there. I can do any dimensionality I want to. But you have to start from the one-dimensional relationship. Now, when you do this, it's very common that people make algebra mistakes because they don't know what to do with this cube. And the answer is that not only do you cube the units, you have to cube the value too. So we're going to write that here. Cube value and the units. So what that means is that when we do the algebra here, we'll have 1 cubed, inches cubed, which is just 1, equals 2.540 cubed, centimeters cubed. If you cube one thing, you got to cube everything. And then I don't remember what 1 or 2.540 cubed is. I think it's like 16.9. I'm spitting out answers in scientific notation. There we go. 16.39. So 1 cubic inch equals 16.39 cubic centimeters. And then I could say, well, if I wanted to figure out what my conversion from cubic centimeters to cubic inches was, so like what is 883 centimeters cubed in inches, I could just do the dimensional analysis. If I can type it in my calculator correctly. There we go. And I got 53.9 cubic inches. So if you've seen a Harley Davidson engine, on the side, some of the larger bikes will actually say the displacement just in cubic inches, and then others will actually just say it in cubic centimeters. So like a 1200cc engine is 1200 cubic centimeters. But in cubic inches, it's like 101. But bigger numbers are more manly, I guess, so that's why they list the numbers in cc's and don't give the units. So like, oh, this is a 1200 Sportster. I have an 883 Sportster, which is a really good first motorcycle, by the way. If you're looking to get a Harley and start riding, get a small Sportster and then get a bigger bike when you can afford it. There you go. Now that we've talked about cubing units and Harley Davidson, let me know if you have any questions. I'm not a paid advertiser. But I do really like my Harley. I wish that I had more time to write. Problem O on the practice worksheet. We can do that after the lecture. I suspect that we're going to finish this early because there's not that many more slides. Hold on to that question. And in fact, I can go over that during the break if you'd like to. I'm not a Harley purist. Like, there are other perfectly good motorcycles out there. I just don't really like crotch rockets because they're tiny and they're kind of quiet. And if somebody is zooming past me at 120 miles an hour, I want to be able to hear them so I don't, like, accidentally steer into them. All right. Let me. We'll put the rest of the text on the screen here, and then I'll clear this right here. Now, on a quiz or an exam in a sit-down setting, like when you were in the classroom, I would normally give you the one-dimensional units, and then you would do the squared operation or the cubed operation yourself. Because this is online, these operations already exist for you. So if you type in 1 inch cubed to cubic centimeters, Google knows how to do that. So this is kind of a triviality. However, you might have to actually do that with units that don't exist, as you're going to see on the next slide here. So knowing how to do this is important. All right, let's do an example here. What's the volume of this soda can in cubic centimeters and inches? And me getting PowerPoint up isn't enough. I have to actually click over here. We'll make that a little bigger. All right, so I have this. This is how much soda is kept in like the little tiny cans that you buy. I call them tiny because I always buy like 2-liter bottles of soda. So what we want to do is we want to figure out this into cubic centimeters, and then also into cubic inches. So we can do this stepwise, because we just did the cubic centimeters, cubic inches thing on the other side. Anybody remember the relationship between these two, milliliters and cubic centimeters? What was that? That's a really useful relationship that you should keep in your head, because if you keep looking it up, you're going to feel silly. But, you know, if you keep looking it up, eventually you'll remember it, so that's fine, too. Yeah, they're the same thing, right? So, in reality, I could just cross this out and write cubic centimeters, and that would be fine. But let's actually do the dimensional analysis here, just to show that it works. So here we go. My units cancel out. Now my answer will be in cubic centimeters. And it's 1 to 1, so I get the same number out. And then I need the relationship between cubic centimeters and inches. Well, I still have this from before. And if I cube everything, I get the result that we had on the previous slide. 2.540 cubed is 16.39. So that means that when I go back up here to do my dimensional analysis, I could then turn cubic centimeters into inches. And I can do it this way, and then just plop down the numbers. Or you could do it this way. Both of these are effectively the same method. It's just which of these ways do you want to do it to organize it in your head. So this relationship in the parentheses is valid, but it would not cancel out over here until I cubed it, right? Because this cubed would cube this 1, this inches, this number, and then that. Okay? Now, if you do it this way, you run the risk of forgetting to apply the cubed to this 2.540. So just be very careful. If it helps you to do all of the organizational stuff down here and then just import all of the relationships up at the top, totally fine. Whatever works for you. So when I punch this in the calculator, I get 355 divided by 2.540 cubed, or divided by 16.39. And the answer that I got in my calculator was 21.663, which will report to 3 sig figs, because that's how many my first number had. 21.7 inches cubed. All right. So that is the dimensions of a soda can. All right. All right, so now that you've seen the gist of it, what I want you to do is use these different units to figure out. Oops, I didn't mean to do that. To do this dimensional analysis problem here. So we have volume on this faraway planet, and I've sort of just made up some units here. So we have a one-dimensional unit, Zorg, and a three-dimensional unit, cubic Blarg. I think I misspoke. I read the problem incorrectly. Okay, so the one-dimensional unit is Blargs, and the three-dimensional unit is cubic Blargs, and then volume is measured in Zorgs. Here's the volume of a certain amount of tea in a cup. And so what I want you to do is figure out this volume in this mystery unit here, and then use the results to turn that into cubic inches. And I have some relationships here that will help you, and these are all approximate. Let me type that in my calculator and see. 16.39. So you're going to get a different result, but remember, when you round it down to sig figs, you will get the same result after we truncate. So 21.663 is what I got when I cubed it, and then 21.659 was what I got when I did the 16.39. So it'll be close, but not quite the same, but when you round it, it should be the same. These are inexact, by the way, because they are one measurement system aligned to another. So these are inexact. The one you could treat as exact, but these numbers on the right are not. So the first step to figure out the volume should not actually involve any cubing stuff. Like, it's already been cubed for you. But the second one will. So try these two problems, and then I'll answer these questions in the chat. Okay? Good luck. We're all counting on you. Now, once people start getting the answer, I have like a conceptual question for you too. This is train or for you to practice thinking about how big numbers are. If you were to give this teacup to a creature, how big would that creature be? Would they be like an elephant? Would they be like a Godzilla? Would they be an ant? Would they be a mouse? Like, try and imagine how big your answer is, and I'll show you the answer in just a second. All right, so we got a few people that have the answer in the chat here. So let's go to the problem previewer. Gotta make this bigger. We don't really need this top part, so we'll just do that. All right, so let's do that. All right, so for the first problem, we have to turn Zorgs into cubic blargs, and we have a unit for that. So I know that this equals this. That should say BG. There you go. So that means that if I set up my units like this, these would cancel out, and I'd be left with whatever this is. And then I just do the numbers. So 132.5. And we're all set. I believe somebody said 4940. And that's what I got too. There should be 3 sig figs in this because each of the numbers that we used had 3 sig figs, so we're good here. Now I got to go from this unit to this unit. And I know that the relationship between these two is that this equals this. So if I want to get cubic inches out of here, I got to cube this side and also cube the blarg side. So when I do that, I get this 3720 BG cubed equals 1 cubic inch. So I could take that as up there, or I could just cube it in the problem. You will get a slightly different answer depending on what you do, because cubing this number will keep all of those extra numbers. This is technically the more correct way to do it. But again, because of how error works, when we're rounding, when we round this down to 3 sig figs, as long as we have 3 sig figs in the problem, it won't affect our answer. So I'm going to do it this way to put this cubed up here. This cubic blarg will cancel out with this cubic blarg, leave me cubic inches. And it's 4940 times 1 cubed divided by 15.5 cubed. We get 1.3265, which rounds up to 1.33 cubic inches. All right. That is a very, very tiny cup of tea. Who would use such a tiny cup of tea? The answer is, and I got to make sure I have it on the correct screen here, because it will capture the wrong window here. There you go. So if you guessed, oops, I didn't mean for it to appear automatically. So if you guessed Roadhog, you were correct. Very good. There he is. I don't know who plays Overwatch here. I don't, but there you go. The correct answer was Roadhog. I would have also accepted like mouse or small creature, but Australian guy riding around on a motorcycle in Overwatch, I guess. I don't know much about the character's background. I just liked the picture. I thought it was appropriate. All right, so let me close that window and go back to this window. There we go. All right, so that's how we take care of cubic dimensional analysis. You could apply the same thing to area. So like if you had to turn inches squared into, or I'm sorry, inches to centimeters, or inches squared to centimeters squared, or maybe inches squared to feet squared, or something like that. You do that with area, you just square both sides. If for some reason you had to do that to the fourth dimensional power, I don't know what the relationship would be for that, like what it physically would be, but you do the same process. All right, the last bit that we're going to do in this section, we're going to talk about converting from anything. There are so many problems out there that you're going to see, and those problems are going to involve relationships between two things that are just linked by circumstance. So, for example, how many glasses of water do you drink per day? That would be a relationship of time, days, and glasses, the number of glasses that you drink. That relationship is related by the words per. Whenever you see per in a sentence like that, what that means is that you would write the relationship as a ratio. So maybe you're supposed to drink 8 glasses of water per day. So you just write that. Maybe you're going 72 miles per hour down the highway. Or maybe you throw 26 donuts out your car window per tree that you pass. Like, that doesn't make any sense. I'm just making up shit here, obviously. But you can make any relationship you want. Whenever you see per, you're going to have a relationship like that. And then, of course, because these relationships are valid, as written in this orientation, you could flip them upside down and write them in that orientation, too. Because one day would require you to have 8 glasses of water is also true. So either of these orientations of the relationship are valid. The same as it would take 1 hour to go 72 miles if you were going 72 miles per hour. Like, those are all valid. And then I'm not going to bother to flip over the third one, but it would also be valid for whatever problem context you are looking at. Okay? So whenever you're doing a problem with these weird conversion factors, look for the word per. Sometimes the word per will try to be disguised. Maybe it'll be something like, I traveled 72 miles over a time period of 20 minutes. Then you would just say 72 miles divided by 20 minutes. That would be the relationship. Okay? But look for per because it's almost always there. And if it's not, look for something that's synonymous with per. Okay? Here's a problem that I initially had written as a much larger number of pounds per day, and somebody was like, wow, that's disgusting. Who eats that much food? So I've reduced it. It's still kind of large. Let's suppose somebody eats 2 pounds of food per day every day. How much food will they eat in 85 years? You know, when they finally die of a coronary for eating 2 pounds of food per day. Select all. That's what I gotta do. Boop, boop. All right, so our relationship that we have here, and I'm going to just start putting some stuff down here. So I know that I have 2 pounds of food in a day. That's how much this person consumes. It's the same person throwing 26 donuts per tree at the window. All right, and the other piece of information that I have is that I have this many years of time to work with. And I know that I want to figure out how much food is eaten in 85 years. Now, I didn't give a unit of how much, so let's just say pounds for this. Normally, I would give you a unit. It could be kilograms or something like that. So what that means is that when I'm making my relationship sort of tree here, this is obviously what I'm going to start with, and this is what I'm going to end with, because that's what the problem is asking, okay? So I'm going to turn years into something, into something, into something, into food. Pounds of food. And then what I'm going to do is fill in the gaps here. So I can turn years into days. And I know how much food the person eats per day, so I'm already all the way there. Let me try that again. There we go. So this is my sort of thought process when I do these types of problems is, hey, what number am I starting with, and what other information will get me there? In general, whenever you are given a problem, don't start with the relationship. So don't start with the ratio. Start with the number that's by itself. And so we'll set up our dimensional analysis just like this, like we planned on the bottom there. And now I can just do the numbers. I'll fill in the numbers with what we got there. So how many days are in a year? Don't forget leap year. So there are 365.25 days in a year. And this person eats 2 pounds of food per day. And so what we get out I get that as my answer. How many of those numbers do I get to keep? I get 2 because this has 2 sig figs. This is 5 sig figs. What about this? That's also 2 sig figs. These ones on the bottom are exact, so that means I only get to keep 2 sig figs here. And that my answer I would report to is that. So if you eat 2 pounds of food per day, by the time you're 85, assuming that you also ate 2 pounds of food when you were a toddler and a child, which is not likely, you will have consumed 31 tons of food. Where does all that food go? Well, that's a really shitty question, so I'm not going to answer that. Dun, dun, dun. All right. How much am I paid? Well, in like 2014, when I wrote this question, this was valid. The lecture that I'm giving you, I'm paid $82.50 per hour. And you might be reading that and going, holy crap. Wes makes a lot of money. And the answer is, well, I don't technically work that many hours in the grand scheme of things when I am doing this sort of work for you. Well, I'm trying to encourage you guys to get a college education, because then you too can be trapped in the academic education system. I'm not trapped. I actually love my job, but as you're going to see in this problem, that being paid this amount over 10 weeks, not so great. All right, so that's what the instructor is paid. And that's for a class of 24. We're going to assume that it's just one class of 24, and then we'll talk a little bit about this later. How much money is earned for 20 two-hour lectures for this class size? Now, in this problem, there's actually a hidden second conversion. And that is that one lecture is 2 hours long. And that's kind of important, because you're going to see here that I got to get rid of this hours somehow. How many lectures are given? Well, there are 20 of them. And in fact, that's more or less correct for this quarter, right? We're going to have 20 lectures, not counting lab stuff, because lab stuff is calculated independently. But using all of this information, I could then figure out the number of lectures that are given. And once that's done, I would then know the number of hours that were worked. And once I know the number of hours that are worked, I can figure out how much money is made. So let's start over here. And then I'll turn lectures into hours. And then we'll turn hours into money. All right. So over a 10-week period, the instructor would be paid $3,300. That's hardly enough for rent in Seattle. So before you go thinking, oh, wow, Wes is a millionaire because he's making so much money every hour. No. Not quite. In fact, I would predict that about 75% of you will probably make as much money or more than me. Just maybe not at the moment, but you'll get there. So how the heck does Wes make money? And the answer is, well, I don't teach one 24-student section. I teach multiple of them. In fact, there are 4 24-student sections in this class right now. So I'm actually teaching 96 students, so I can get that times 4, which is actually livable. Like, you can live on $12,000 a quarter. And then the lab stuff adds a little bit more money, too, and stuff like that. But it just goes to show that education isn't really valued in America, and that faculty aren't paid that much. So support your teachers, because when you are older and you have kids and you want to send them to school, teachers are doing quite a lot for your kids, and that's very important. And they're doing a lot for you, too, if you go back to school, for example. Okay. I'm not saying that just as a teacher, but I'm also kind of saying it as a teacher. Please give me more money. I would like to be able to pay off my car. All right. But the purpose of these two problems, as random and weird as they are, is that you can make relationships out of anything. So I'm going to highlight those relationships in yellow. So here was my pounds of food per day. This is how much money the instructor makes per hour. And then also this right here, each lecture is 2 hours. That's a relationship too. So in these types of problems, you're going to have to look for the relationship and then use those units to get from your starting value to your goal. All right. So I'm going to give you, 2 problems for you to try along this nature. So here's how much aluminum costs per pound when I looked it up to make this problem. I think aluminum might be a little more expensive. I'm not sure, actually. How much does a metric ton of aluminum cost to purchase if it's 93.17 cents per pound? And then secondly, if this is how much sodium is in your blood per pint, how many pounds of sodium are in 10 pints of blood? You might have to look up how much volume a pint is. But yeah. All right, so go ahead and give these problems a try. We'll go over the answers in just a second. I'm going to go get more water. And then once we go over the answers, we'll take a break because we're at the first hour. Okay, see you in a bit. How are we doing? Any questions? Let me know in the chat. We'll give you about 5 more minutes, and then we'll go over the answers. All right, let's go over some of these answers so we can get to our break here, because I don't want to run over our time. All right, so let's start here. That kind of glitched out on my screen here. Hold on. There we go. So select all. All right, so for this problem, I know that aluminum has a cost of this per pound. If you've ever seen something that costs fractional cents, in fact, most people have, it's called gasoline. There's always that 9 at the end, so why is it 263 or $2.63 0.9 per gallon? Well, it's when you buy a ton of them, that extra 0.9 of a cent actually matters. So that's why commodities like that have more decimal places than 2, even though we don't actually have fractional pennies. So I have this relationship. I know that 1 metric ton is exactly 1,000 kilograms. And I want 1 metric ton of aluminum. I don't know what the prefix is for metric ton. This actually looks a lot like milliton. I'm going to put a little dot here. It's supposed to be metric ton. So I could turn my metric ton into kilograms. That's easy enough using this relationship. And then I have a relationship between pounds and money. So if I can get kilograms into pounds, I can then get cash money by doing that. Yeah, a milliton would be a kilogram, right? So it's supposed to be a metric ton. All right, and so let me set up my units first here. Oops, I didn't mean to color pick. There we go. So metric ton to kilograms, kilograms to pounds, pounds to $sign. So let me write my relationships here. So 1 metric ton is 1,000 kilograms. So we can put those numbers in. Kilogram is 2.204 pounds, I believe. We'll have to look that one up if that's not right. And then 1 pound is 93.17 cents, according to that conversion factor. And it is just coincidence that we have all these numbers on the top. In fact, if I had looked up a different relationship for pounds and kilograms, I could have a number on the bottom instead. So I get 1 times 1,000 times 2.204 times 0.9317. And I get for my answer $2,054. All right. So again, we're just following the rules of dimensional analysis. Step 1, set up the units. Step 2, put in the numbers. Step 3, do the math. Same thing we've been doing on Tuesday and Thursday last week. All right. Oops, I'm out of space, but I can fix that. Canvas size, anchor up, pixel or percent. Let's see, height 200. Boop, there we go. I gotta do this though. Boop. And then, oops, I need my pen to not be in black. All right, there we go. So for the second problem, how much sodium is in the human bloodstream? If these are some quantities that are relevant. All right. I'm missing something on that problem statement because I'm looking at that. There we go. I'm like, there's no numbers here. So there is 1.52 grams of sodium per pint of blood. And a human has 10 pints of blood. We'll just do that. So I need to turn the number of pints of blood into grams of sodium. And once I have grams, I can do pounds of sodium. So I need some relationships here. That's this relationship right there. And then for the relationship for grams to pounds, I'm just going to look that up. 453.6 grams of anything is going to equal 1 pound of anything. So now that we're all organized, we can set up the units here. So I have 10 pints of blood in me. How much salt is in there? Well, if I turn pints into grams of sodium, and then I turn grams of sodium into pounds of sodium, those units will all cancel out. And I did something dumb here. Sorry. There you go. Now you should be able to see it. All right. So according to our numbers down here, 1 pint was 1.52 grams. And there were 453.6 grams per pound. How much salt is in your body? Or at least in your blood? In pounds. And the answer that I got was 0.03351. How many sig figs should there be? Well, this is 3. This is 3. This is 4. So this should have 3. Then again, of course, if you stream on Twitch, you may have more or less salt in your blood at any given time. All right, we're going to take a 10-minute break. That means that we get to go here. I get to turn on the timer. Boop. We'll start the timer, and then we'll go back to playing more Mario music. So I'll see you in 10 minutes. Have a good break, and we'll be right back. That's close enough. All right. Welcome back. We're going to move on to the last part of the section. Finish off Chapter 3 today. Unit 3. I keep calling them chapters. And we're going to work with percentage. Percentage is actually a relationship. It's just something out of 100, right? For example, if 70 of my 100 and whatever students liked, I don't know, chocolate, I could divide those two numbers together and get a number out of 100 as a decimal and make a ratio. Or if I asked 100 people on the street, who are you voting for? I could get a percentage of how many are going to vote Democrat and how many of them are going to vote Republican, for example. You can do any relationship that you want to out of 100. And that's what percentage is. It's basically the same process that we've been doing so far. The word per means divide, just like before, and then cent in this context is century, and century is 100. So percent is per 100. What you're going to do first is you're going to index the number of items of interest that you care about, and then you're going to divide by the total number of items, which may or may not be 100. But once you have made that ratio, you can then times it by 100%. And that will make it out of 100. So let's do an example of that. Ooh, what did I just do? I dropped the pen on the keyboard and I hit a random button. And I don't know what button that was. Oh, I can do this. This is a thing that I can do. I can make my lecture video require a strobe or seizure warning. So, I don't know, let's suppose that out of the 120 students in this class, that 84 of you like the music that I'm playing during these breaks. I don't know. And then the other people, take off their headset because it sounds terrible. Whatever. So, if I do that ratio here, 84 divided by 120, I would get this. Now, because these are counted in items, this number is exact. What that means is that 70% of the students like the music if I just pick these numbers. To make that a percent, what we do is we then times it by 100%. So the decimal place just moves over to, and we get that. So you don't necessarily have to have 100 things to do this. As long as you know the ratio between the items of interest and the total number of items, the times 100% part takes care of that for you. All right. Let's suppose that I had data that shows that 37 out of 45 people passed my 140 class in some quarter. What percent of students pass the class? Well, the way that we would do that is we would take... I don't know why I'm doing it on the screen where there's no space. I have all the space ever right here. Oops. There we go. Could not select layer. That's not what I meant to do anyway. There we go. Alright, so we have 37 students of interest. And then the total number of students was 45. And then we'll take that value and times it by 100%. So 37 divided by 45 is 0.822222 times 100% equals 82.222%. And again, because those are counted numbers in my counting my students, I have infinite sig figs for my ratio here. You don't have to write infinite number of 2's there, otherwise you'd be there forever, obviously. The 100% is also an exact number, so just keep that in mind. In the context of this problem, these are exact because I'm counting. But you may not be using exact numbers. For example, if you estimated population, so like maybe 4 out of 5 doctors agree, like that's definitely an estimate. It's not exactly 4 out of 5 because there are way more than 5 doctors out there. Or like, I don't know, 50% of the population of Earth is female. Like that's an estimate. There's no way I could actually have counted every single person. So those numbers would be inexact. But depending on the context of the problem, you may be using an exact or inexact number. So just be mindful of that. I clicked on the wrong thing. There we go. Here I only reported 2 sig figs. I should probably have reported more, but that's okay. All right. Now, these relationships can be used as conversion factors. So in this example, we're going to explore that a little bit. So, oops. Let's suppose that I have a specific alloy of steel, and that alloy is 94% iron by mass. What mass of the 5 kilogram steel bar that I've got is iron? Let me scroll this up here so that I'm not writing under the guide. All right, so I know that I have a 94%, and it's 2 sig figs, it looks like. Iron steel bar. And so what that means is that that's the same as me saying that in 1 kilogram of steel, I would have that many kilograms of iron, right? So in the other problem, if you have that on Canvas, how would you put a repeating number like that? On Canvas, I pretty much always tell you to put it into 3 sig figs, because for a lot of the numeric problems, Canvas doesn't know what a sig fig is. So when I give it a problem and say, accept this answer, I set it to a certain number of decimal places and then have the answer round around that number. And that's kind of the best that I can do. So on Canvas, follow the number of significant figures that the problem directs you to do. In very nearly all cases, it will be 3. There may be some cases where I ask you to do more or less. All right, so this relationship right here is just these things put together, and we can use this right here to solve the problem. Because if I have a 5 kilogram steel bar, and I set up my units like this, well, here's kilograms of steel and kilograms of iron. That would cancel out. And that would give me a mass of iron. And so, if there are 0.94 kilograms per 1 kilogram of steel, then my problem is just 5 times 0.94. And that's 4.7 kilograms of iron. There you go. All right. How about this problem? How much oxygen is present in 1.25 liters of air if air is 21% oxygen? Turns out air is 21% oxygen. This is actual data. So I could use, I don't actually need this on the screen, we'll just get rid of it. I could use this relationship here, so 21.0% O2. That's the same as saying in what volume we're working with. So let's say 1 liter of air. How many liters of oxygen would there be? Well, there would be 0.21 of them, right? Because air is 21% oxygen. Now, if you're having trouble getting these decimals out of here, another way that you could write this is you could say, okay, well, if I had 100 liters of air, how many of them are oxygen? Well, it would be the same number, right? And then when I do this division, that's how I get to this number here. So now we have the relationship set up, which means that I could say in my 1.25 liters of air, if I do this, make this relationship so that these cancel out, and then I can get the answer, except I don't really get the answer because I don't want liters of O2 for my answer. I actually want milliliters of O2. And now I can do the numbers. What's the relationship between liters of air and liters of O2? It's just this, like we determined below. And then what's the relationship between milliliters and liters? That's just 1 and 10 to the minus 3. Because again, remember, you want to have something on each side of the bar to make the equality. Milli is 10 to the minus 3, so we'll set them up this way. All right, and then we'll punch it all into the calculator. 1.25, 0.210 divided by 1 times 10 to the minus 3. And you should get that. And then finally, we'll check for sig figs. 3, 3. This is exact, so infinite. So this should be 3. And there you go. Now, why is my ratio not exact? It's because you can't count individual molecules. They're just too tiny. So that counting process is not accurate. If I was saying that like a bag of marbles was 21.0% blue marbles by number, then that'd be different because I could count all of the marbles in the bag if it was a reasonable size bag. Molecules are like marbles, but there are septillions of them, and that's an underestimate. Since we can't count all of those, so that number is not going to be exact. That's going to be an approximation. Wouldn't I round down? So that if you bankers round in this class, that's fine, but I personally don't. I don't round to the nearest even number because statistically speaking, we aren't working with enough samples for it to matter. So I'm just using standard rounding. If you put in 262 as your answer in Canvas, I would accept it. Where am I on here? There we go. All right, I think I've got... Here we go. So here are my 2 problems that I want you to try. This right here is a number that has a space in it. This actually is supposed to have a comma, but for a lot of students that are from countries that are not America, when you see commas, they look like decimal points. Or you don't see commas, you interpret commas as decimal points. So this space right here is actually all one number. So this is how many words that you can play in Scrabble. And of those words in Scrabble, 5,846 of them have exactly 4 letters. Tell me what percentage of words in Scrabble are not 4-letter words that you can play. And then secondly, here is what trimix is. This is a specific mixture of gases for people to breathe when they go deep sea diving. And so one particular composition that I looked up was 21% oxygen, 35% helium, and the remainder was nitrogen. What's the volume of each gas in a 12-liter scuba tank with those percentages? So use the percent formula to figure out these problems. So we'll go over the answers in just a second. And then I think we'll call it a day. That might be it for this. Oh, there's 2 slides after this. Okay. I'll give you a few more minutes to finish up. Go ahead and type your answers in the chat once you get them. I see people have already been doing that, so that's good. So Photoshop doesn't like my video card, and when I scroll, this happens. Woo, I get artifacts. Boop, and then they're gone when I hit a button. So that's what happens when you use old software. That's not what I wanted. There we go. And we'll do this. There we go. All right, so we got to make a percentage here. So we need words that are allowed, or 4-letter words, and then words that are allowed completely. So there are that many 4-letter words. That's a lot of curse words. There are this many words that are possible to write down times 100%. The units cancel out. And when I do this calculation, I get... Oh, I didn't times by 100. I get a really long number. Like that. Now, these are words that are going to be 4 letters. So to get the not 4-letter words, I would have to do something like this. 100% minus 4 letters percent must equal not 4 letters percent. So I do 100% minus this number. And what my calculator spits out is 97.89457004%. Because these are all, it's all exactly known. So you could report as many significant figures here as you wanted to for this problem. It would all be appropriate. In Canvas, I would tell you to report a certain number of sig figs. Because otherwise, you'd just be there forever. All right. I actually looked up trinix because I didn't know what the composition was of it. But we have a mixture that is 21.0% oxygen, 35.0% helium, and the remainder is nitrogen. Well, everything has to add up to 100%, so the nitrogen must be 100 minus whatever the O2 is minus the helium. which looks like 44 and 2. And so now we just do this problem 3 times for each of the gases. So if I have 12 liters of air, then I could set this up as a percentage. This is the O2% right here. So I could say in 100 liters of air, there are 21 liters of oxygen. Or I could use the decimals that I was using before. In 1 liter of air, there were 0.21 liters of oxygen. Whatever works. And so I get 2.52 liters of oxygen. Everything is 3 sig figs, so we're good there. Now I can do the same thing with the helium. Here's how much air we have. This will just be my percent. For this, let's see, there it is, 0.35. Like, uh-oh, I lost it. Did I scroll it off the screen? No, it's right there. Oops, I almost put hydrogen. That's actually helium. And then for the last problem, for the nitrogen, we could do the same thing. Oh, I messed up. Hold on. So those cancel out. We could do liters of nitrogen and just do this. Or what you could do is you could say, well, if there's 12 liters and I've already got the volumes of these two, I could just do 12 liters minus 2.52 and then minus 4.20. And the answer that you get here should be the same as this one. The issue with this is that you're going to start losing accuracy based on the first number. You'll get a different number of sig figs. So given the option, doing the multiplication route is the better route because you'll get to retain sig figs that way. Here I got 5.28. But if I did it this way, we would have ended up with 5.3. All right, any questions on how we did those two problems? Let me know in the chat. I got 2 more slides to go over for today. Then we're done with chapter 3. That's the wrong window. There we go. The last thing we want to talk about is percent error. Percent error is just a calculation that is used to figure out how close a result is to the correct answer. Percent error is something that we would use to gauge accuracy. If you remember accuracy from chapter 1, if you had a percent error of like 5%, then you were fairly close to the right answer. If you had a percent error of like 0.5%, you were very close to the correct answer, and so on. Like generally, we try and be within 5% of the correct answer. The correct answer being what we call the true value. Or in other words, whatever the accepted literature value is. The measured value would be your result for whatever you did. In the laboratory, generally you would calculate your result, and I would provide the true value as the answer that you're trying to get. And then you would do this relationship to figure out the true value. Now, in this relationship, the sign matters. If your result is smaller then the true value, the result of this operation will be negative. And as a result of that, if you subtract a smaller number from a bigger number and then do percent error, you'll get a negative percent error, which is what you're going to see in this problem here. If the true density of aluminum is 2.71 grams per cubic centimeter and a student gets 2.63, what was her percent error? Well, she would just do this. So her result minus the true value divided by the true value times 100%. And so you punch that in your calculator and you think, oh, this is easy. I got 2.95 or negative 2.95%, and I would mark that wrong. And you'd be like, what? Why is that wrong? And the answer is, well, let's look at the sig figs. So I'm going to leave my calculation on the screen there, and then we're going to do the calculation stepwise here, and we're going to see where the issue comes up. Someone asked me, why don't I update my drivers? It's actually the program. My drivers are up to date, but my Photoshop is not. Because now you have to keep paying for that stuff, and I should really just find a free art program or something, or at least a cheaper one. All right, so I'm going to write down the calculation again here. And we're going to do order of operations. What's the first function? Oops, I got to put my times 100% here. That we're going to do. Oops, I don't know why that... Oh, that probably looked like a link to Google, so it's like, I don't know what's going on. So what's the first function that we're going to be doing? It's going to be this one, right? So that means I need to do subtraction. 2.63 minus 2.71. And once I do that subtraction, I get this. I can go to this position because everything lines up. Now, that looks really stupid how I've written this. The way that you actually should do linear subtraction, if you don't have a calculator handy, is that you just flip these numbers around. And now just subtract them as if they were normal. And the minus sign was down there. So this is the result of the top of that expression. So let's rewrite it. And now you'll notice that, oh, I only have one significant figure here. So when I do all this division and multiplication, my answer is going to only have one significant figure in it. And so when you do all that calculation, the result that you get is this. So when you do percent error, it's very important. Be careful with sig figs. Because when you do percent error, you have a subtraction operation immediately followed by a division operation. And the rules are different, which means you have to consider the rules before you move to the next step. Okay? So for percent error, this will often happen, and it's very easy to make a mistake if you aren't careful. Okay? So make sure that you are following the rules for sig figs and doing order of operations so that you don't accidentally report too many sig figs for your percent error. Now, what does the negative mean? If you get a negative percent error, that means that your result was smaller than the true result. If you have a positive percent error, then that means that your result was greater than the true result. The sign on your percent error tells you which direction you are off from the correct answer. So there is some information that can be gained from that. But some formulas and some versions of this put absolute value bars around the top of the expression to get rid of that minus sign. I prefer to have the minus sign because you do get something out of it. And so I'll expect you to give me a percent error without absolute value. So keep the sign on it. All right. Let's erase all that and put this on the screen. So here is a practice problem that you can try right now. We have a few minutes, so you can figure out the percent error for each of these students. What I'm going to do is I'm going to calculate it really quickly, and I'll just write the answers on there at the end, and then we'll call it a day. So I'll give you 3 minutes to give some of these a try, and then I'll put the answers on the screen. And then we'll talk about what we're going to do tomorrow. Okay? See you in a bit. All right, in the interest of time, let me go over the answers with you for these. I did the problems real quick, and I was like, oh, I should probably go over these with everybody. So you can keep working if you'd like. But the whole point of this is to have... What is this window right here? Oh, it's just trying to capture something. Let me just delete this. I keep clicking on a box. So for sample A here, we get this. So we have to do the subtraction first, and when we do that, I round around to this position, I would get that. And then this number divided by 2. Where'd my swap? There we go. 2.705 times 100% will give us, what did I get on my paper here? I got 0.74%, which only has 2 sig figs because of this number right here. Oops, we'll leave that on the screen there. All right, let's look at B. B is 2.510 minus 2.705 divided by 2.705 times 100%. Got to do my subtraction vertically here. So 2.510 minus 2.705. I'll move this number up to the top and just do the subtraction in my head. 8, 1. Is that right? No, it should be a 9. So this becomes 0.195. It's negative because I'm subtracting a larger number from a smaller number. So when I do the calculation here and punch it in my calculator, I got negative 7.21%, which has 3 sig figs because this guy had 3 sig figs. So you'll notice that the number of sig figs is changing based on how close the number is to the true answer. If they were exactly the same number, I would subtract 2 numbers together. I'd just get 0, which isn't any sig figs, so it'd just be 0 as an answer. If I was really, 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 really close, I would have only 1 sig fig for my answer. And that's because as your answer gets really, really, really close to the correct answer, your error gets harder to define. The number of sig figs tells us how well our error is known, but if your error is extremely small, it's hard to measure it. So don't be discouraged when you look at it and say, oh, I only have 1 sig fig that I can get out of this. That's because the correct answer is very close to your answer, and it's hard to pin down your error. All right, so finally, number C here is 2.801. I don't know why I'm doing this one in black when I was doing the other ones in pink here. 2.705 times 100. Got to do this again. We'll subtract vertically. So I have now this, which I then put in the calculator, and the result that I got was positive 3.5%. 2 sig figs in my answer because this value only had 2 sig figs in it. All right, so that's how you do percent error. The big thing that's going to catch you on percent error is that the number of sig figs that you enter is very, very important. I'm going to test you on percents and percent error and stuff in lab number 2, so you're not really going to see much of that on the Unit 3 quiz. You're going to see mostly dimensional analysis because that's easier for me to program. That's it for Unit 3. Let me get the celebratory orc on the screen here so that we can all celebrate. Hooray, there it is. Oh, I didn't get any music there. Hold on. Hooray. All right. That is the end of today's lecture, and that is the end of Unit 3. What that means is that Unit 3 has its own quiz. So quiz 2 will become available immediately following the lecture. I would advise you not to immediately go try and take quiz 2. If you have not done all of the practice problems in the worksheets, in the workbook if you have it, and the practice problems from the recommended reading. Let me know if you have any questions. I'm going to officially make the last call announcement after class. I'm going to set the deadline for, I don't know. I'll see what it is when I write out the announcement. But check for that email. Make sure you get that quiz in before before that deadline happens. Okay. Thanks a lot for watching. I hope everybody has a good rest of your day. When we come back on Wednesday, tomorrow we're just going to be doing a Q&A. So bring any questions about Chapter 3 that you want me to go over with you, because that's the perfect time to do it. Okay? Have a good night, and I will see you tomorrow.